Okay. Topological index is a number, right? It is a number. It is a numerical value. Nilai numerik. Tak tahu bahasa. So this actually can a numerical value that can be calculated from a two-dimensional graph. So why a two-dimensional graph? Because a graph that represents a molecule. So topological indices are normally a numerical value found by chemists, ahli kimia dengan molekul, ya. So this information from a graph is converted into numerical characteristic for this particular one. So we have somehow a molecular topology, and there is a molecular property from the molecules, and we get a number. And why this is used by chemists? Okay, why this is used by chemists? Now, because they want to find, like, for example, boiling point somehow. So if people ask why we are studying about topological indices, chemists use this. And this is much simpler than really doing it and boiling it and using all those experiments. Yeah? And they use the degree of vertices and the distance. So degree, distance, they're all in the part of the formula. And who introduced the first topological index is called the Weiner index. Nidia, you wanna guess who introduced this index? What's the name?
Weiner.
Weiner. And you are the winner.
Oh, amen.
So this is introduced by Weiner in 1947. Yeah, he introduced this Weiner number, and he compute the boiling point of alkanes, right? You take any chemistry class before, like in high school or in university, or not?
Last time in the first semester, so it's 3 years ago.
But it's okay. At least we know there's such thing as chemistry, right?
Only the numerical.
Okay, so this is the main application of this. Now, we want to see about the Weiner index. Yeah, the Weiner index. Okay, so we want to let gamma to be a connected graph. Nidia, you can screenshot from there, right?
Yes.
Take some screenshot, then you email me later. Then I put in my Facebook. This is how the Indonesian students see the class in UTM.
All right.
This is my anyone that take
NHS. Is it? It's not really clear.
NHS.
Oh, NHS.
My name.
NHS .my.
Okay, so let gamma be a connected graph with a vertex set B gamma. Say we have 1 until n. Yeah. Then the Weiner index denoted as, of course, W, right? W of gamma. This is actually half the sum of the distances of every pair of vertices. So we write like, because we want it every pair, right? So we go I from all the indices and then J from all the indices. N. I want to change this to N. Okay, I from 1 to N. Where Bij is the distance between VI and VJ. Let me try to see myself from the speaker view to make sure, yes, I can see my writing. Otherwise, we call it like short sendiri. Short sendiri means you just do it no matter what people see or not. Okay, so I think this is clear, right? Just now we have looked at what is the distance between two vertices. So you change the J first. So you go like I1, I2, right? And then you choose the I. So you choose one I, say you start from I equals 1, then you go through all the J's. Then you raise 1, meaning every single pair, you have to count the vertices. All right. Okay.
Professor, just to be clear, is it the shortest path for every two vertices?
This is how we define the distance earlier, right? The shortest.
Oh yeah.
Yeah.
Okay. Thank you.
Okay. Now let me give you in-class exercise. Later on is our tutorial. Is different. This is in-class exercise to make sure all those students, they are here or not. I don't know. I just see the name. At least the ketua kelas ada ni, dia is there. Okay. Okay, so I give you this graph, yeah? But this is 5. So 1, 2, 3, 4, 5, E1, E2, E3, E4, E5, E6. Okay, it has to be connected, yeah? That's why in the Weiner, the definition is given for connected. Okay. Now, calculate the Weiner index. So now, this say 1 until 5, right? I 1 until 5, D of I, D. I give you 3 minutes. 3 minutes. How many times you have to calculate? 5 times 5, 25 times, right? Don't forget the 1/2 outside. So the first one will be like D11. This is the first one, right? And then you have I equals 2. Then you add this until, then you have 3, 1. Then you have 4, 1. Then you have 5, 1. Until at the end. Okay, and then all this. Okay, as one example, take this one. So I take this side. So 1, 1 is 0, right? 1, 1 is 0. 0. 1, 2 is 1. 1, 3 is 1. 1, 4 is
2.
1, 5 is?
3.
Okay, so this one is 7. And then give me the answer.
I get
15.
30, all of them.
What's the answer?
I get 30.
I got
30.
15.
30 will be
Oh.
15, yeah?
Yes, like that.
Okay. That's correct. A plus. That's quite easy and straightforward, right? Okay. All right, I will give you the Weiner index of these 3 types of graph for the 3 type of groups. Okay, so we have those. Will not give the detailed proof because that will add up to our class to maybe 1 month. I'm just kidding, but just give you the okay, I think this is clear. Yeah? I can give you any type of graph, then you can see, then you can start from 2 for this one, right? So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and so on. I think this one is straightforward. Once you get the graph, it's pretty easy to get all this. All right. Okay. Now let me give you the Weiner index of those 3 graphs associated to our 3 groups. All right. So the first one is the, I call it proposition. I don't know why, but in my notes it's already 18. Yeah, because all those things I call it proposition. Okay, so the Weiner index of the non-commuting graph of the, oh, this is in general, eh? This is not yet for DN. This is in general. We can actually find the Weiner index of the non-commuting graph in terms of the order of the group and the order of the center for this one. So there's an easy formula already. It's 1/2. Okay. The order of G minus the order of the center, okay, multiplied by the order of the group G minus, let me rewrite here, it's too long. You don't have to erase, yeah? It's just, I wanted to write in the 1 line. Okay. 1/2. 1/2. Okay. The order of G minus the center. Yeah. The order of the center. Okay. Multiply by the order of G minus 2. The order of the center minus 2 plus the order of G multiplied by the conjugacy, number of conjugacy class minus the order of the center. And all divided by 2. Oh, okay. There's a proof for this one somewhere. So we have to multiply all by 1/2. But take the order of the center, subtract that from the order, multiply by 2 times the order of the center, subtract that by order of G and 2. Then we take the number of conjugacy class minus the order of the center, multiply that by the order of G. So we got to this theorem. If actually you want to do this in general for the group, a big group, you imagine how many times you have to take the double summation, right? So they come up with this proposition. So the Weiner index of the non-commuting graph of D to N, okay, again, we have to separate into 2 because just now even the conjugacy class, the center, right? We separate into two cases. So using that, then you can prove that putting in this in here, you get this. Okay, and half. Then you get a number, right? This is a square, multiply this, you get a number. When n is odd, then you get some number. When n is even, you get some number for the Weiner index for this particular graph. All right. I give the proof in the notes. You can go through the proof. Okay, it's quite straightforward by substituting whatever I gave you earlier, right? There is the order, there is the center, there's the conjugacy class. This morning, you plug in, you will get directly these two. You should try that out yourself and just to write out and see. It's pretty straightforward. All right, and you have to do two cases, yeah? Or n even. The next one would be the Weiner index of the conjugacy class graph for dihedral. Oops, I don't want to erase that, but I did. But anyway, let me call theorem 2. Okay, I'll finish this and then we take a break for 10 minutes, right? For the last one. I mean, the 15-minute is like, why is it very, very fast? I don't know why. Maybe is it my watch? Or it's real? Or because I'm standing? I don't know. Okay, so this is quite short, yeah, of the what is this? D. Okay, this is for the conjugacy class graph, yeah. It's just straight this. Okay, and also I give you the details of the proof. How do you get this? By definition. Okay, by definition, you can figure out the distance, okay, of the dihedral group for the conjugacy class graph. All right. Okay, and then we have the Weiner index of the co-prime graph. All right. So the Weiner index of the co-prime graph of the this one depending on, this is when n is odd prime. Okay, this is when n is odd prime. The Weiner index of, yeah, for the dihedral group when n is odd prime. Okay, so there is also the Weiner index of the first graph for the second group. The Weiner index of the second graph of the second group, the Weiner index of the third graph of the second group, and also the third round would be the Weiner index of the first graph of the third group, okay, and so on. So this one, I have to stop before we go to our tutorial. Is that all right, Nidia? You are the class monitor.
Yeah, that's totally fine.
Okay, take a break of 10 minutes, yeah?
Okay, thank you.
Okay. All right. Okay. Okay. Are you here, guys?
Hello, hello,
Yes,
Professor.
Can you just show your face, everyone? Just for 2 minutes. Boleh ya, betul-betul ke rambut, makeup, tudungnya. Okey, baru nampak. Oh, tudungku sengit. Ini semua rambut MCO ya. Kalau di Malaysia dipanggil PKP. PKP apa? Movement Control Order. Apa ya PKP? Dah lupa dah bahasa Malaysia. PKP pun dah lupa. We are still under MCO actually. Sebab online, right? Online class. So some students they are just don't think they need to turn on the video, so boleh aja baring-baring sambil ni ya. But it's nice to see everyone. Let me call your name, whoever is here. Yeah, I have called Media, Putri, Andini for many times. Sharif juga, I call your name. Akbar, Zaki, Rambu, Maya, yeah, Rizki. How do I say your name? Wanha, Sonia. Apa itu?
Anwar Sania.
Okay. Ananditya?
Ya, Ananditya.
Ananditya. Okay. Apa tu? Karina.
Karina.
Karine. Okay. Clarita. Okay. Nikita. Ya. Yeah. UGM ya. Saya pernah sampai UGM. Sri Nurhayati. Ada? Oh, Zahidah ada hari ni. Petang ni. Okay. Lailatul Maghfirah. Right. Dwi Nurul Istiqomah. I know Istiqomah is in Arab. So
Yes.
Shadam. All right. So, okay. Now, I already actually uploaded the tutorial. It's okay, Zahida, it's okay. Sometimes we are there, but we are not here. I understand. So I already uploaded actually this tutorial. The tutorial one is on the Weiner index of conjugacy class graph of dihedral group of order 10. So I just take one because we now only know Weiner index, right? Weiner index, we take one, the second graph, conjugacy class graph, because you have learned about the non-commuting and the other one, right? And conjugacy class is new. So number one, find the conjugacy classes of D10 using, well, if I ask you to do it using definition or proposition, but you can use anything as long as you find the conjugacy class, yeah, of D10. Okay, you can use A and B, right? So D10 is generated by A and B. A to the 5 is B squared is 1. Okay, use that. And we also have a proposition how to find the conjugacy classes of D2. And you can actually use that for B by using the result in A, sketch the conjugacy class second question, prove that the Weiner index of Kn is 1/2 n minus 1. Okay, prove that the Weiner index of a complete graph of degree n is 1/2 n minus 1. The third one is compute the Weiner index of the following molecular structure. Okay. C has to be connected into 4, right? 4 atoms. So C to C, and then we have this. This is actually for ethane. Etana, I think, in our language. Etana, kan? Ethane, yeah? Okay. How do you write this in the C2H what? Kan, right? I don't know. My chemistry is like so many years ago. Your chemistry, if 5 years, mine is like maybe 30 years or so. So you can transfer this into like 1, 2, 3, 4, 5, 6, 7, 8, right? And this is the connection in between them. Okay, how many minutes do you need? 15 minutes, maybe? We try, ya? Ya, Akbar? Tak dengar suaranya, you have to unmute you. Like you're talking to yourself. Okay? So, we try for 15 to 20 minutes. I will ask whether you are done or not. Okay. Then you can write nicely. Okay? After this, then I will ask someone to share. Then you can take photo, right? Take photo. Then you can share screen. And then we will discuss. All right? Okay ke tidak? If it's okay, everyone, you do like this reaction. Okay? Okay? Okay. All right. If you have any question, just ask. I'm here. Media sudah sampai mana?
Number 2 and number 3, but I haven't finished number 1 yet.
Oh, okay.
I skipped the number.
Okay, okay, that's fine. Anybody got number 1? No? Yes? No? Yes? You know, if Malaysian, normally the Malay, diam tanda setuju. If you quiet means you agree. Okay, number 1 semua sudah siap? Jangan diam. Kalau belum, kena cakap belum. Okay, maybe we add more minutes, yeah? We add more minutes until 2:30. Because I want you to try. Okay, I want you to try so we see our solution. Which part that you have difficulties, which part that you do understand, which part that you don't understand. Okay, we have 7 more minutes. Actually, Nidia, I'm sitting just here. So if anybody want to call me, just shout out, like Roniza. Yeah?
All right.
There is no chair here, I see over there.
Okay. So we basically unmute our mic.
Yeah.
Okay.
Okay. Right. Any takers for number 1? Okay, no takers? Yes or no?
Only 1A.
Okay. How do you get it?
By using the where is it? By using the proposition.
Uh-huh.
So should I just say the conjugate clauses?
Okay.
The first one is 1.
Mm-hmm.
The second one is A and A
Inverse.
inverse.
This is the case when n is 5, yeah?
Yes, so
n
it's
is
odd.
5, so you take the odd one. Okay.
Yes.
A inverse.
And then the second
How
one
do
is
you say inverse in Indonesia?
it's still inverse.
Oh, okay.
Yes.
A squared, A negative 2.
Yeah. Then the last one
Okay.
is
The next one is still the same thing, right?
yes.
N minus 1 over 2 is A2, so it's already here. So the
Mm-hmm.
last one is
AB.
AIB, right?
Yes.
IB 0 less equal to I less equal n minus 1. 4.
4. Yes.
So which is equal to B,
A-
AB,
AB, A3B, A
A squared B,
squared B, A
A.
cubic.
Okay.
Yes.
Now you find the conjugacy plus graph.
Oh.
Okay. So the conjugacy plus graph, this one out, right? Okay.
Yep, it's the center.
So this one we call it like CLA, right? This is CLA squared. Then here we call it CL of B. Just one representative. Okay. And what is the order? What is the order? What is the number?
2.
2.
2. 2.
2.
1, 2, 3.
4.
1, 2, 3, 4. Right?
Yes.
Okay. So how do you draw? How do you draw the edges? The edges is if the order is coprime. If the order is coprime, that is conjugacy class graph. Okay, if the order, the GCD is not 1. Okay, so this one and this one, 2 and 2 is 1, right?
Yeah.
Yep.
Okay. What about this?
It's not connected because
4. Because the number of classes B is 4.
Mm-hmm.
And the number of classes of A or A square is 2, and 2 and 5, 2 and 4 is not coprime like that.
The GCD of 2 and 4 is 2, right?
Is
It is
2,
not,
right? Okay, yes.
it is not 1. So it is connected, right?
Yes. Yes, it's adjacent.
It's adjacent.
Professor, can I add something?
Yeah.
Why in classes of the last classes is not the 4 power is not include these classes?
I just put it there because I want to see if you see or not.
Okay. Okay.
Okay.
Yeah. Thank you, Professor.
That's the trick of a teacher. Okay, so it is not connected because this 1, 2, 3, 4, 5. I know you have 5. That's why you said just now it's not co-prime, right? So this
Yeah.
is the graph of the conjugacy class of D10 is equal to, we write K2 union just this, right? Plus of there's a dot here. So it's K2 union this. Okay? Okay. Number 2. Any question here? It's clear, right? Okay. Because Y is connected. Because a VI is connected to VJ if the order of VI and VJ is not 1. Or GCD is not 1. Or they have common factors. This one is 2. This one is also 2. So the GCD is 2, which is not 1. So they connected, or the edges, right? And this one is 5. So 5 and 2 is co-prime. This one also is a co-prime. So that's a single there. So this is not a connected graph. That's why I didn't ask to find the Weiner index. It's not connected. All right. Okay, if you okay, please show your jempol ya, kalau orang Jawa panggil. Tunjuk jempolnya. Jempol. Okay. Ada jempol. Siapa yang tak tunjuk jempol? I don't know, maybe you still thinking. Alright. Okay. Now, can somebody show number 2? You have, if you want to share, I can let you share. Okay, Nidia, mau share?
Actually, my number 2 is not really well written.
Okay.
It's better if I explain it through words,
Okay,
maybe.
okay. All right, it's okay. So we want to find W of Kn, right?
Yes.
So if you have n of this thing, right? All connected, right?
Yes.
So they're all connected. So this is half sum, right? Sum of
Ij. Yes.
J 1 to n, I 1 to
N.
So next one is you have, I put this first, yeah? D1, right? 1, 2 until
So
1n.
1N.
Okay. Then you go to 1, to 2 until
2N.
Dot.
All the way down to
1
N1 till
and 2
NN.
and n. Alright. Okay. 1 to 1 is 0, right?
Yes.
What about the rest?
The rest is 1.
Okay.
Oh.
0 plus 1.
1
plus 1
1
plus 1.
Until 1 for n minus
at-
1 times.
Yes.
Yes.
Okay. Okay. And then the next one,
It's also the same.
but 1 first and then 0,
0.
right?
Oh, yes.
1 plus itself,
0.
because we move to the second one.
1 plus 1.
1 again for n minus 1 times. And we did this. So this one is 1. This one already n minus 2 times, right?
Yes.
And then you do it until n times, right?
Yeah.
Okay. So you get 1/2 n because there are n times. N
And
minus
-1. Yes.
jempol ke tidak jempol? To me, it's a jempol. Okay. Okay. Then this one, yeah? Okay. All right. Okay. Number 3. Okay. So this one, let me put the name maybe. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So again, I put like this. Okay, I from 1 until 8, right? J from 1 until 8. Okay. So this one you really have to count, right? You really have to count. So for example, start from 1. Start from 1. 1 to 2 is 1. 1 to 3 is 2. 1 to 4 is 3. 1 to 5 is 2. 1 to 6 is 2. 1 to 7 is 1 to 3. 1 to 8 is 1 to 3. So this is only for D1J, yeah? D1J. So this is D1J. This is equal to 16 then, right? 16 for the first one. And then you have to start 2. Start from 2. Okay? So this is for the first one. You have to do this 8 times. Right? So you start from 2.
1,
2, 1. 2, 1. 2, 2.
0, 2, 3,
And
1,
you put 1, 1, right? Which is 0 actually, right?
0. Yes.
There 0 here. 1, 1. Okay? 2, 1. 2, 2. 2, 3. 2,
2,
4.
4,
2, 5.
1,
2, 6.
1,
2,
2,
7. 2, 8.
2.
Done. Okay, 1, 2, 4, 5, 6, 10, right? Okay, now 3, 3, 1,
2,
3, 2,
1,
0,
0,
1,
5,
2,
3, 5, 2, right?
2,
2,
3, 6,
2, 1, 1.
1, 1.
and 1.
It's same.
10. Okay. 1, 2, 3, 4. 4 is like 1, right? Because it's
Yes.
Yes.
okay. 5 also, right? You will get the same. 5, 6,
7, 8. Okay.
so I think
116,
20.
it's
88.
8.
Oh, 58, yes.
Jempol.
My bad.
Jempol. Okay. Okay. So, so I hope that this first day is clear to everyone. Okay. I skipped some of the parts in which there's the Weiner index also. So remember, we have 3 groups, and then we have 3 graphs. But I focus on the conjugacy class graph because you have seen the first one and the third one, right? In the other class, non-commuting, and also the co-prime graph. So I concentrate on the conjugacy class graph. Sometimes we don't use the definition because it's hard to find even the conjugacy class by formula XA, X inverse. So we come up with a proposition with the property, just use that and plug in, and then we get the conjugacy class. And you can think of, if some of you really like algebra or pure mathematics or group theory or graph theory, you can start thinking, if you want to continue for masters or PhD, some topics that you can actually further. This is the beginning. You have the basic, and then you have some properties, and then you make it more general, and then you apply, and there are many applications which are actually very interesting. So I hope that today's class is clear. All right, this is how I teach my class actually in UTM. During pandemic, I use my office, And I use this board because to me, it's much better to see the lecturer's face looking at you, right? Rather than it's just small, and then when you write, you don't even see all the writings. I hope this is okay. If there is anything that you want me to improve for your next class, let me know. There is just now my email, right? This is for my name, Nur Haniza Sarwin. And we don't stop just now. Anytime, even if you want to come to Malaysia or UTM next time, can contact me. But do drop me an email before the next class if you have any suggestion that I can improve. Okay. So for the next class, we have the 3 hours for the 3 other indices. All right. We have 3 other indices. I will upload before the class, the latest the day before. Tomorrow is Eid. So to all celebrating Aidil Adha, Selamat Hari Raya Aidil Adha. So because we don't go anywhere, so I don't plan to like cook. Zahida, normally we ketupat, rendang, all those things. I have not seen my mom actually. She's in Kuala Lumpur with my sister since January, so I have not seen her for that long, but it's okay. Raya is every year, so inshallah next year we still have, but we have to take care of ourselves. That's the most important thing. Okay, if anyone wanna say something, let me just summarize today. We have seen for 3 different groups, we have seen 3 different graphs, and I shared something about the properties of the groups, so that is used to find the graph, to determine the graph, including the center and the conjugacy class. Okay, I didn't go one by one because my intention is more to the topological indices, but I want you to learn at least a new graph, at least along the way. So what we have seen today is just the Weiner index. So I'm sure it's quite clear, right, with this tutorial and how actually you collected. And later on, I've also shared about why people are computing these topological indices, because of the boiling point of all the molecular structure of the chemistry. Okay,